Hello and welcome back to the second video for lesson 9.4. Wanted to break this into two sections. So example 4 says a new prep class was designed to improve SAT test scores. 4 students were selected at random. Their scores on 2 practice exams were recorded, one before the class and one after. The data recorded in the table are the scores on average higher after the class. So that's what we wonder. Test at a 5% level. So here are the scores before taking the prep class, and here are the scores after. And they're wondering if the after are higher. And so our hypothesis can be written two ways, but I'm going to do after minus before, thinking it's going to be positive. They would go up. So if I take 1920 and subtract 1840, I would get an 80. If I take 2160 and subtract 1960, I would get a difference of 200. And so on and so forth. And now notice student 4 is going to be a negative 500. Student 3, 2200 minus 1920 would be 280. So my HO is because this is a paired data, meaning that it's the same sample measured twice. We are looking at the mean difference is equal to 0, or the mean difference is, I'm going to do greater than 0, because I'm doing after minus before is greater than 0. So here is the formula for my test statistic. That's going to, you can either calculate it by hand if you want, but it can be done in the program for the one sample means. And that's because when we take the differences, we now only have one sample of data. So we're going to head to Desmos, and I'm going to calculate the mean of this sample, standard deviation, and so forth. Okay. So here are my befores, my after, and then I subtracted my after minus my before and got the mean and the standard deviation. I found my this is the t-score here. So this is the test statistic. So I took the mean and subtracted what we think it is, which would be 0, all divided by the standard deviation divided by the square root of n. So my test statistic is 1.77, and we're going to go to the Desmos program, and then we'll validate that that's true. Then our t-score is calculated down here with degrees of freedom, and it's a one-tailed test. So I'm going to do 1 minus 0.05, and I get my critical T of 2.353. So if we go to the means program and type in what we have here, so okay, so I'm going to type that in 127.5, and the standard deviation is 144.08. And then our M0 is 0 because we think there's no difference. And that's validating our test statistic that we calculated by hand. We don't need to worry about the alpha because it's not a confidence interval. It is a test of greater than. And so there is our p-value. which is 0.087. And the alpha is 0.05. And so when we go back to our paper, the p-value is the method that we're going to use. And so the p-value from the program is 0.087, which is greater than alpha. So we do not reject H0. So on the final exam, I'll mainly be just asking you to get the p-value from that program and use that to compare to alpha. So we did not reject H0, so there's not sufficient evidence. To say that the prep class improved the scores, at least on the campus side. So let's look at example 5. Example 5. The 7 8th graders at Kennedy Middle School measured how far they could push the shot put with their dominant writing hand and their weaker non-writing hand. They thought that they could push equal distances with either hand. The data were collected and recorded in the table. So here we have dominant and weaker, and it is paired data because it's the same sample being measured twice. And they want us to go ahead and test this. And they gave us the differences of taking the dominant minus the weaker. So 30 minus 28 is 2, 26 minus 14 is 12, 7, a negative 1, 2, 0, and 4. And so the hypothesis is equal to 0 and HA is not equal to 0 because they just want to know if they're different. See whether there's a mean difference is significant. So let's go to our Desmos. You've got that Desmos link in the module, so you can be following along with this. Try these on your own. So we're going to the shot put, and there it is. There are the differences we calculated, and the mean is 3.71, and the standard deviation is 4.499. And I calculated the test statistic, which is 2.184, and the critical T is 2.447. And remember, it's always n-1, so your degrees of freedom go in for that critical T value. And then, like we did before, we can always validate this by going to the means and typing in our data. 0.1. And that validates our test statistic, 2.182 here, but just rounding, I had 2.184. And then this is a test of not equal to, so I'm clicking on this one here on row 41, it says, but and then we're going to go down. Our p-value is 0.0719. And then we'll go back to our paper and we're going to compare that to our alpha. So there's our test statistic. Here's our critical T value. Our test statistic is not further away than our critical T value. So that would also say it's do not reject. And then our P value is greater than our alpha. So that also indicates that we do not reject. And so that would be out here. The p-value is there. So let's just look at the last example for lesson 4. It says 5 ball players think that they can throw the same distance with their dominant hand as throwing with their offhand. They collected some data and they want us to test at the 5% level. And it's just testing if the differences are significant. So it's an HO is the mean differences are equal to 0. And HA are the mean differences are not equal to 0. And so we're going to get all of this from and this over here really should have been like a two shaded, even though my p-value, when it's a not equal to, it's kind of split between. This is just going back to example 6 for, or example 5 for a minute. Okay, example 6 here also has 2-tailed, so we're going to shade both of them. And then we're going to go to our Desmos work for a moment. And so there's that. And so they did, we did dominant minus the offhand. So our mean and standard deviation, and then our test statistic was 3.208, and our critical T is 2.776. And so on this one, our test statistic is further away from the center than our critical T. So we're probably going to reject H0, and we can confirm that in our means program up here. I needed to write down my and test statistic. That's supposed to be 5. There's the correct test statistic is 3.58. I mistyped there. So make sure you divide by n. Degrees of freedom is n-1, but you're dividing by n. Okay. I had to check my eyes there for a minute. Okay. So back to that. Our p-value. I'm going to go to the not equal to. So our p-value is 0.023. And let's take that back to our paper so we can finalize everything here. And just like I mentioned, our test statistic is further away from the critical T, which would mean it's in the danger zone. And that also is in agreement with the p-value is less than our alpha. So we do reject H0. So there is sufficient evidence to support the claim. that throwing with the dominant hand is different than throwing with the offhand for the ball players. So catch me back for some more videos.